So just remember that your test is going to be on Tuesday. Unfortunately, Monday, Mrs. Hill and I are both gone, but Mr. Schmeling is in the Resource Center a little bit, and he can answer questions. Otherwise, the rest of the math department is asked to answer questions. So just so you know on that, okay? So let's talk a little bit about the trig functions that we have, okay? So when we're dealing with trig functions, okay, they are functions just like they're algebraic functions, okay? So what is the independent variable in a trig function? We talked about this in November. I can say that. Anybody remember what the input? What do we put into a trig function in order to get something out? We put an angle, okay? So we're going to put an angle into the function. Okay? So our independent variable is what we put into the function. We put in a function or in an angle. We trigify it. What do we get out? Now, the radian measure would be the angle that we put in. What do we get out? Just a number, right? Yeah, we just get out a number. We get out a value. Okay? So we get out the dependent variable. It's what we get out of the function. We get some value, and that's going to be some number. Okay? Now, let's specifically focus in on one or two of those today. Okay? So now let's talk on the unit circle. So now we're on the unit circle. What does the y part of the ordered pair represent on the unit circle? That's the sign. That's the sign of theta. What does the x part represent? Cosine. That represents cosine. That's going to tie into the sheets that you all grabbed up when you came in the room. Okay? So, if I want to graph, that's what this next unit is all about. We're all about graphing the sinusoidal functions. Now you understand why our fish was named sinusoidal. Okay? Right? So we're going to be graphing the sinusoidal functions. So we're going to graph sine and cosine today, and then next week we're going to graph tangent, and then we're going to graph cotangent, and we're going to graph cosecant, and we're going to graph secant. We're going to graph them all, and then the second half of this unit, we're going to fit a function to a graph. We're going to go backwards. Instead of you making the graph, we're going to give you the graph. You're going to make us the function. Okay? So that's what it's all about. So, same here. The independent variable x was the angle. The dependent variable y was the trig value or the number value that we get out. Okay? So if I am graphing it on the xy plane, normally this would be x and this would be y. This is the normal plane. But now, in the trig plane, my x is going to be an angle measure, which if you notice on your graph that you picked up, that's why you have nothing but angles on your x-axis. Because that's your new input. Your output is still that value, that number that you get. Okay? Everybody with me so far? So let's start with sine. We want to graph the sine of x, or really it's y equals the sine of theta. Okay? And this is where the spaghetti is going to come in. So if you'll notice, you should be on the sine side of your graph. There's a sine and a cosine side of your graph. Okay? So if we're on the sine side of our graph, what we're going to do, or what you are going to do, is you are going to take your piece of spaghetti, and you are going to, I'll go with green here. I want to make it a little bit bigger so you can see it. So these are broken up into how many degrees roughly are each of those radii, representing how many degrees? 15, right? Okay, because this would be, so 15, 30, 45, 60, 75, 90. Okay, so each one of those makes 15 degrees. Now, if you'll notice on your graph is broken up into 30 degree segments. Okay? So we're going to skip the first one, and we're going to go to the second one. You guys just told me that y is sine, yes? So using your spaghetti, your piece of spaghetti, you are going to go to the 30 degree, and you are going to measure it vertically with your spaghetti. Okay? Then you're going to take that piece of spaghetti. You can either mark the spaghetti, or you can break off a piece of that spaghetti, or whatever you choose to do is you. Okay? So then you're going to take that measurement, and you're going to apply it to your graph. And at the top of that, you're going to put a dot. With me? So we're measuring vertically. And you're going to need to go all the way out here to 360 degrees. And we'll stop at 360 degrees because that's all the way around your circle. With me? Go. Have at it. Measure all the way around the circle, graphing it as you go. What happens in the sine when you're graphing and you get past 180 degrees? It goes negative because now you're going below that center axis. So you should have started at 0 because that's the first one. Then at 30 it should have been at a half. Then at 60 it should be at 0.86. Then at 90 it's at 0.1. Then at 120 it's back to 0.86. Then at 150 it's there. Then down to here. Then it's down to here. Then it's down to here. Then it's all the way down in there. And then it comes back up a little bit. Then it comes back up a little bit. Then it comes back up. So if you draw yourself in a nice smooth curve, you get that. Yes. We call this the first lap wave. And when we graph stuff, this section, we're going to always graph the complete first lap wave. Okay? Because that's how it takes to get back to the start. Okay? What can you tell me about the sine wave, sine curve, sine graph, whatever you want to talk about? What can you tell me about it? There's a lot of stuff that you can tell me about it. Its range is -1 to 1. Is it ever going to get outside of that range? Is it ever going to get lower than -1? Is it ever going to get higher, bigger, or higher than +1? Nope. Nope. So it's stuck in that range. Okay, that's a good thing. And we learned that. Actually, we learned that in the obviosities. That was in one of our. That was, I think, number 1 in the obviosities. The sign doesn't get any bigger than 1 or any smaller than -1. Okay. What else can you tell me? What if we graph 2 laps on a wave? It would the pattern would repeat. It would keep waving through like that. Okay. So really, the actual function goes on and on and on forever to the right, and it goes on and on and on forever to the left. That was another obviosities that we learned in the last month. Okay, was that if we add 2 pi, we're in the same spot. So we can take any of these points that we graph, add 2 pi or add 360 to it, and we have the same spot. Okay? So it keeps going on and on. Anything else? Last class came up with it's oscillating. We also came up with that it's symmetric. So there's symmetry in it. There's a couple of different reflections and rotations. Good. All right. Now, what about cosine? Cosine is what on the unit circle? It's the x values. So now what you're going to do, same type of thing, now what you're going to do is you're going to, instead of measuring the vertical distance, you are now going to be measuring the horizontal distance. Oh, let's go with that. And so you're going to say, all right, so here's my 30 degrees. That's what I'm going to be measuring now. That horizontal distance to get there. Okay? Now, the hard part is, easy part for you, hard for me to show up here, is that now you have to take this and I have to rotate it. I thought there was a way to rotate. Recognize owner, lock, link to tool, flip. Can't flip it. I want to flip it. Left, right, up, down. That's not going to work. Yeah, but you got to rotate that around, and you're going to graph it vertically. Yeah. So on the circle, you're going to measure horizontally, but on the graph, you're going to put it on there vertically. Okay? Go for it. Graph me a cosine wave, first lap wave. So we should start up here at 1, then we should come down to there, then we should come down to there, then we should come down to there, then here, then here, then here, then that. There, and so that our curve looks like that. What can you tell me about the cosine curve?
Well, smack another one on it and also has the
Symmetry again. Okay, a little more symmetry on this one, right? Okay. All right. Now, this is going to be a little difficult for you to see by just looking at your paper. So what we've done, went and did, is we went and put it on Desmos. Okay. So the front side of your paper should look like that. Right? The back side of your paper should look like that.
Whoa.
Okay. What can you tell me about it?
Just move.
So they're the same curve, right? Let's say since we started with sine, we'll start with sine. Okay? What is different about the cosine curve? Like, start vertically in one?
Yeah,
Okay? So, but are they the same curve?
yeah, they're the same.
What's different about them though?
It's a translation.
It's a translation. So let's put that in everyday English terms. A translation is a movement, a shift, right? So if I shift the cosine curve, that's the blue one, which way would I have to shift it so them to actually match up and be exactly the same?
Technically, either
I'd have to go to the right, okay? How far would I have to go to the right? No. Look at yours. Look at yours now. Okay?
Oh.
How many degrees? Because that's what pi over 2 or 90 degrees. If I shifted blue to the right 90 degrees or pi over 2 radians, now they match up as they say in My Cousin Vinny. Identical. Okay? Identical. Okay? The only thing that I ask is that your spaghetti ends up in the garbage can, not on the floor or on the table.
And you have to get the was called instead of the 2 years.